So we're talking about working memory and how it impacts students' learning in the classroom and our instruction. I'd ask you to take a look at a series, a couple of puzzles. And you'll notice in the first one, this one right here, okay? All right. I want you to pick the puzzle piece that fits into that puzzle. Not too hard, right? Pretty easy, okay? Then I want you to take a look at the next puzzle. And tell me which puzzle piece, oops, which puzzle piece fits in or completes the puzzle. Okay, do you have it? Okay, number 5. Okay, now let me show you one more. If I can find it here. You'll notice on the, if you turn the PowerPoint to the next series, the next page, you'll see another one if you're looking at your PowerPoint. If you don't have that up, I'll show it to you here. Okay, which puzzle piece fits here? Which makes this puzzle piece complete? Okay. What did you notice about those 3 puzzles? Many of you will realize that first puzzle, they're all basically the same task. Complete the puzzle with the puzzle piece, right? You notice the first one was really easy. You didn't even think about it. You're just like, oh, that's easy. Did you notice the second one? Did you find yourself staring at it a little bit longer, taking a little bit more time, trying to figure out exactly what's going on? Yeah. How about that third one? Did you notice yourself really spending a lot of time? Same basic task, pick the piece that completes the puzzle. But everything slowed down. Why? Because the demand on your working memory. You had to pay attention to more things at one time. And because you had to pay attention to more than one thing at a time, 2 things, 3 things, you had to pay attention to a lot of stuff, you felt everything slowing down. That's the same thing that goes on in the classroom. The more demand that you place on your students' working memory, the amount of information they can hold on to, the more information that they can work with, everything seems to slow down. I have over here on the whiteboard a visual representation of what we see. This comes from Robbie Case's work and others that will study working memory capacity with kids. But anyway, you'll see right here, you'll see it's a staircase, right? And the staircase progressively goes up from 5 to 15. 5, 7, 9, 11, 13, 15. And what we find, and this is Juan Pasqualeone's work and everything, what we find is that students' ability to attend, to process information, their working memory capacity, basically bumps up a piece of information every couple of years. So at age 5, they could routinely work with a couple bits of information. At 7, they could do 3. At 9, they could work with 4, 11, 15, all the way up to about 7. That's that magic number, 7 plus or minus 2 that Miller describes, right? What that means is people can routinely, as you get older, can work with more information, more things to juggle at one time, up until about 15, which as adults, it really doesn't matter too much. About 7 is that kind of that capacity. Now, can we increase it a little bit? Yeah, we can increase it by what? Chunking. That term chunking is just grouping multiple numbers, grouping multiple items together. Might allow us to hold on to a little bit more information, but not a great deal more. And so the idea is we recognize that it is very age impacted by age. When kids are 5 versus when they are 15, working with 2, working with 7, that means our instruction is highly influenced by how much the students can process. Young kids can only attend to so long. They can only work with so much. You get a little bit older, you can work with more. I always laugh. If you've ever watched a teacher in fourth grade, fifth grade, all of us, I'm guilty of it as well, but working with students, say they're doing a lab, a science, and they have taught the kids how to use the microscope, and they're going to do something where they look at the microscope. The teacher says something like this. Okay, I want one person from each table to go back to the back of the room and to pick up the microscope. Remember how we pick up the microscope, how you hold it, okay? And then on your way back, I want you to stop off and get a slide and make sure you get the tissue paper also to go along with the slide to come back. Oh, hey, I forget before I forget. Friday, the permission slips for the field trip are due. If you don't get them to me by Friday, then we're not going to be able to go next week over to WIU. So anyway, I just want to make sure you remember. So make sure you grab the slide and the tissue paper as you get going and you come back to the table. Students come back and suddenly somebody's got the microscope in front of them. The teacher's like looking at you like, hello, get the tissue paper, get the slide, get the whatever. And they're like, weren't you not listening? And the student, if in all honesty, they're probably like, yeah, I was, but then you started talking about permission slips, and then I started thinking about that, and I got to remember this, and I just forgot. Yeah, whose fault is that? Okay, we throw in students, fourth grade. Okay, think about the amount of information they're working with, right? And then suddenly we try to give them a list of 6 things, 7 things, and we interrupt it. And suddenly the students are lost. Happens all the time. We forget about putting too much working load on their capacity, and as a result, the students just kind of misplace things mentally or forget stuff or get distracted. That happens all the time. So as teachers, we have to think about the impact of those demands of the tasks that we give our students. So the implications for the classroom are we can't overburden the students' working memory. You got to think about our use of technology or how we use things. Sometimes we can go through things fast, like a PowerPoint, click, 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 click. Can students process that information that quickly? Probably not. So we have to slow things down. We have to take that into consideration. Okay. So the idea is once we have our students' attention and we get things to their working memory, okay, then the goal is to get stuff to their long-term memory. Now, what is it that when we're talking about with their long-term memory? It's basically where students hold on to certain knowledge, skills for a relatively long period of time. Maybe forever, maybe not. We're not exactly sure. Hard to test 75-year-olds on everything that they've learned over the course of their lifetime, right? But what do we know about it? Well, what we do know is that their long-term memory has an unlimited capacity. The more information in long-term memory, the easier it is to store information there. Why is that? Think about it like this. Remember we talked about the brain and how the brain works and the connections that are made and the neural connections, the synaptic connections that are being made, the memories that are being formed. Well, when you have more information in your working long-term memory already, you're going to find greater opportunities for you to access and connect information, which is then going to help it to store it more effectively. So we store information in our long-term memory in different forms: visual, auditory, smell. You think about it. Think about the smell of fresh cut grass. Think about the smell of somebody making banana bread. Think about the nails going down a chalkboard. Oh, okay. We store information in many different ways. But in either form, because of short-term memory being a bottleneck, long-term memory occurs slowly. What do I mean by short-term memory or working memory being a bottleneck? What I've done is I've taken the model over here, sensory register to working memory to long-term memory, and I flipped it on its side. You see this here? Sensory register, working memory, long-term memory. What image do you see? What image might come to mind when you take a look at this, the model being flipped on its side? Besides the capital letter I. Okay, I see that, right? Some people, if you take a look at the outer edges, might look like a little bit like an hourglass. An hourglass. What do we know about hourglasses? Sand filters from up top, goes through the small little constricted area, and then it goes to the bottom. But what we realize is that middle area where it's smaller, it constricts the amount of sand particles that can go through there, right? It's the same thing for processing information into our long-term memory. Working memory acts as a filter, like a bottleneck. That's why you can only process so much information at one time. You could see a lot of stuff, but you can only process the stuff you attend to. And there it's even limited. And then once you get it to your long-term memory, yeah, then we can store it there for quite a long time. But our working memory acts as a filter. Okay, our long-term memory is very interconnected, right? We talked about those in the past with how the brain works. Information may be stored in more than one place and more than one form because memories are linked to previous neurons, to different certain synaptic connections. They're not going to be just one spot where lawnmowers are, right? Information more often used and associated with other information is going to be more easily remembered and more easily retrieved. That's when you think about those synaptic connections that are formed. We talked about the myelination, when things are myelinized. What we find is that myelin, that protein coating, that adds with the efficiency of recalling that information, and that adds with the speed and the efficiency. That's what happens. Use stuff a lot, associate it a lot. That stuff becomes myelinated, becomes much more efficient, much more easily recalled. Right, less energy used. Okay. Information tends to be stored more conveniently than logically, meaning that the greatest fit, the greatest connection, the easiest connection is probably where you're going to find that information. And long-term memory is very idiosyncratic. And by idiosyncratic, I mean unique to each of us. People are different. People have different experiences, different schemes, and with those different schemes, that means you process information differently than your classmates. That's why when a teacher explains something, some people think of it this way or process it one way differently than their classmates because of the unique nature of their memories. I oftentimes do an activity in class where if I said a word for this, for example, I want you to write down the first word that comes to mind after I give you one. Okay? Then, looking at the word you wrote down, write down the next word that comes to mind, and the next word that comes to mind, and the next word that comes to mind until you have 5 words written down. Okay. I will start you off with the first word. The first word is beach. Beach. Write them down. Okay. Look at the list of words that you have. I can tell you that mine, okay, when I say beach, okay, first word that comes to mind for me is ball. Then when I think of ball, I think of basketball. Then when I think of basketball, I think of Magic Johnson. When I think of Magic Johnson, I think of the Lakers. When I think of the Lakers, you see how it goes, it just boom. So I start with beach and I end up with the Lakers. Right? Some of you say beach, and then you say sand, and then you say castle, then you say Game of Thrones, then you say dragons. It goes any number of different directions because because it's idiosyncratic, our schemes that are different from one another, and that word acts as a catalyst, word association, and that's going to take us through that process. Very unique to each one of us. Students experience the same set of things. Now, based on age and experience, if you're teaching 4th grade or 8th grade, you're going to find that many of them are very similar, much more similar than they are different. But they are indeed different. Okay? So, we have to think about once we get information from the sensory register to their working memory, to their long-term memory, okay, how do we help them effectively process the stuff that we do in our classrooms to our long-term memory? And we're going to talk about 5 ways that we routinely put information into our long-term memory.